it's one of the conundrums when one uses metal cladding, particularly, or steel-based cladding, I should say, particularly when you've got metallic coatings, because whilst the coatings on the cladding materials themselves, including all the ancillary items, are designed to be durable when exposed in a given environment, they're particularly vulnerable to damage when not properly stored prior to installation. And the most common cause of damage is what is known as wet storage staining or wet storage corrosion. And this applies to all aluminium, zinc, and coated steel products, including painted versions of those materials, are vulnerable to this form of damage, which ranges from mild, superficial damage to irreparable, where the cladding cannot be used and has to be replaced. It is usually a direct result of moisture or water vapor being trapped between tightly packed layers of material, but it can also occur on surfaces in direct contact with one another. The extent of the damage is directly related to time of exposure. Temperature plays a big role, and the pollutants in the environment in which the material is stored. And in the case of zinc, galvanized and painted surfaces, it's not always immediately apparent when you separate bundles. And if we have a look at the slides that are there, we seem to have lost one. Okay. The top left-hand corner, that's a piece of galvanized material where two surfaces were in contact with each other with a little bit of moisture. There we are. Now you've gone on to the next one. There we are. And that just shows you on a hot summer's day, after 48 hours, there's the white rust starting to appear on the surface. And the bottom left-hand slide is showing you what happens when there's salt in the air after 96 hours. That cladding is completely destroyed. It looks almost like the moon's surface. The one in the middle, top middle, that is an example of color-coated material that got wet and got left out in the open for an extended period. And you can see what's happened to the coatings there. And one's got to remember, when you come to color-coated material, it's invariably color-coated on one side. So on the exterior, the intended exterior surface, you've got your metallic coating, you've got a transition layer, you've got a layer of primer, and you've got a top coat. Whereas on the reverse side, you've basically just got a 5 to 8 microns coating, nominal coating of paint. So paints, when wet, become permeable. They soften depending on the time of wetness, and then the moisture breaks through to the undersurface, as you can see there in that middle photograph. On the top right-hand corner, that is some aluminium material that got wet whilst it was in storage, where the ellipse is. You can see the transition point where it was covered by a sheet above it. And the slide on the bottom shows you the type of staining you get. So with a zinc surface, you'll get that white residue that you see in that middle photograph on the bottom there. And when it comes to aluminium and aluminium zinc alloys, you get a black stain. And once you've got to that black stain state, that material is damaged permanently. It might not have damaged the coating to that extent that it would fail, but the black stain you cannot wash off or clean off. It's there permanently. One advantage, of course, of using aluminium zinc, provided it's from an established supplier in the country, or the aluminium zinc has a clear organic coating on it to prevent mainly fingerprinting, but the advantage is it also prevents initially wet storage staining. And if those sheets are wet for just a relatively short duration, it'll fog, but once you've separated them, the fogging will disappear and you will have a nice pristine surface again.
So then it's just a question, why is it that the surfaces of metals are susceptible to wet storage staining?
Well, all metals try to resort to their natural state, which is basically an oxide of the metal, be it iron oxide, aluminium oxide. And the protective properties come from a thin layer on the surface called a patina. And that's where your durability in a given environment comes from. And until such time as the patina is developed or established, the material is subject to damage. And in the case with your zinc coating, when it gets wet, you get a zinc mix there, and it's transparent. It's almost like a gel. And that's why when you initially separate sheets that have been wet or are still wet, they look fine. And then after 3 or 4 days exposure in the sun, then the white residue starts to appear, and you can see that you've had corrosion there. And this is covered in one of our technical data sheets where we discussed white rust and black rust on the different types of coatings. So people visit the website, they can get a more detailed explanation of exactly what happened.
Super, thanks for that, Dennis. Just a reminder, anybody, if you've got any questions, please do pop them in the chat, or if you want to ask them in person, just switch your camera on, and then we'll call on you to ask your question. Dennis, off you go. Okay,
another thing that people don't normally understand is that polycarbonate products are equally vulnerable to wet storage damage. The polycarbonate itself, if it's exposed to water for any length of time and some high temperatures, it will soften, and you can also get the UV protective layer delaminating from the product. So if you read the brochures from the manufacturers, they caution you against storing the stuff out in the open or under a clear plastic surface or anywhere where you're going to get moisture trapped, and we'll discuss how to wrap and protect the materials as we go along. And another thing that's a problem, which is not always obvious, is that the insulation blankets, if they get wet and you try and install cladding over them whilst they're still saturated, they actually react with the cladding. And if we look at the next slide, there's an example of where metal cladding was installed directly over a blanket, and you can see the type of corrosion attack on the undersurface of the cladding, which of course won't manifest itself for 8 months to 18 months, depending on the environment and the temperature and the degree of wetness. So the big thing is keep it dry. Under no circumstances are coils or bundles of these products to be allowed to get wet. And it's important that when the materials arrive on site, they are checked. Particularly if they've been transported over a number of days or been transported by a transporting contractor rather than the manufacturer or profiler, as we refer to them in the industry. And the best way to avoid any problems with wet storage, staining, corrosion, is to store the materials on a dry, untreated dunnage to start with. If dunnage is wet, some of the preservatives, if it's got preservatives in it, will attack your coating, and that they must be a minimum of 200 millimeters above the surface on which they stored. That surface itself must be firm, quick drying if it's like a roadway or something like that. Preferably it should be an impervious underlying surface that is permanent, or is dry most of the time. And one must understand that anywhere where water pools, or if you've got a soil that's being compacted but is holding any form of moisture, you're effectively creating a steamer, and which is the worst possible scenario, because you've got this fine mist that penetrates through capillary attraction into the tightly packed bundles or where you've got contact surfaces. The worst thing you can do, of course, is to store material under a clear or semi-opaque material, because then you're getting heat into it, and again, you're drawing and holding the moisture that's there. Another problem is if you are wrapping the material for transport and you've done the similar sort of thing, and of course invariably it is tightly wrapped. If when it was wrapped, the air was fairly warm and the humidity quite high, you're trapping that moisture inside this bag, and effectively you're creating a steamer, which is detrimental to the cladding surface. I think the most important thing is that the type of cover must be opaque. It must be away from the upper surface of the cladding products that are going to be stored underneath it. But the most important thing is that it must allow for the continuous free circulation of air amongst these bundles. And of course, it must be effective against wind-driven rain and splashing and splatter from vehicles passing the bundles. So it's very important that this thing isn't the minimum sort of cover just draped over it, like you've got a bundle of sheets and you throw a blanket over it. It's got to be more than that, because otherwise you're going to have problems with the materials being stored in there, particularly if they're there for some time. And we would also recommend that the bundles are inclined at about 3 degrees or more, so that you avoid any ponding if those bundles sag in the middle on that upper surface. And then, of course, the other thing is you've got to make sure it's not leaving the product vulnerable to mechanical damage, and we will discuss mechanical damage in the next few minutes. Our next slide shows you what they use in the Northern Hemisphere and first world countries when it comes to storage. You will notice that there's a plastic ground sheet. You can see the bundles themselves have got corner protection. There's a slope for the drainage, and effectively you are creating a tent. That's the ideal situation to ensure material. And if you're going to be storing material on site for more than 10 days to 2 weeks, you really need to be constantly monitoring the state of that cover, that it hasn't sagged because something's been put on top of it, or it's got a hole in it after a storm, and then making it ineffective or possibly leaking onto the material underneath, and you won't discover it until you open the packs. So I'll be with you in a sec. Just need to move something down here. And as I said earlier, the worst thing you could do is tightly wrap these products, because any moisture is just going to go straight into the interlaying layers. Then we come to the second one, which is mechanical damage. And if we look at the next slide.
Okay, just a second, Dennis, I'll show you now.
Okay, no, that's fine. We'll get there.
I wasn't sure. There was another question that I had, but I'm not sure if now is the time to ask it, or if you've got something else you still want to cover.
No, go ahead.
Okay. Yeah, what I just wanted to ask was about what do you do with wet bundles or packs of material?
You've got to separate those laminal or layers or sheets, whichever reference you want to make, and dry them off. You've got to get rid of the moisture as quickly as you possibly can. And unfortunately, on a site, you don't have the luxury of vast areas where you can take the sheets and lay them out in the sun to dry out. So these things have got to be dried off. And then we recommend, when those bundles are reconstituted, that there's something separating each and every sheet until such time as it's installed on a roof. And much the same would apply if you've got bundles that have been taken up onto the roof and haven't been fully installed in the current working day or the next day because it's been raining. Those sheets need to be separated as quickly as possible, because as you saw in that first slide, on a hot day, the white rust is going to start to form on your zinc surfaces, and on your aluminium zinc, it's going to start softening that clear coating. What a lot of people don't realize is that cladding out in the sun, the surface temperature of a white sheet is going to be in the region of 50 to 60 degrees C. And if it's a dark colored, you could get right up to 60 to 65 degrees C surface temperature. So you can understand you've got a really hot plate there, yeah, in effect.
Sorry, a question, Denise. Yeah, before Dennis moves on to mechanical damage. Sorry if I missed this, but did you say that if it's actually, let's say, zinc coated and then has been painted over that with some organic paint, that it is not vulnerable to these effects, or will that also be vulnerable? That's the first question. The second question is, if it is not coated, how long does it take before you can be sure that the zinc has that patina and will not be vulnerable to this, meaning after manufacturing?
All right, to answer your first question, paint surfaces are vulnerable. And it's a time-related thing. And oh, sorry, one thing, I just want to get rid of a phone here.
We should have fines for people that have their phones on while presenting, Dennis. You have to buy cake for the office. Emmanuel,
I second that.
Do you maybe just want to give a quick, oh, there we go, Dennis is back.
Yeah, sorry, I forgot to turn my phone off before we started. It all depends on the wet-dry cycles. So the longer the paint is wet, the more susceptible it's going to be, and it becomes soft. The other thing that if it's there for an extended period of time, you can also get a color change due to the moisture. So yes, it will take a lot longer, but depending on temperature, pollutants in the air, the amount of moisture, it could be anywhere, in the case of color material, from 5 days to 2 weeks before you would start to notice the damage. Badly, stuff that's been wet for a long time, color, if you separate the sheets, you will notice there's a color change. You can see it.
And
my second, sorry, sorry, Denise, there was a second part, which is,
yeah, go for it.
Yes, how long after galvanizing occurs or after the coil is manufactured can you say that the zinc has formed a patina and it's not vulnerable to white rust, or is there no such time?
No, there is. And the process is that with a new zinc surface, when the coating is put on at the mill, they passivate the layer, which gives you some temporary protection. But it's a process because when your zinc is exposed to the air, you get your zinc oxide, then you get moisture to it, you get zinc hydroxide, which is the clear sort of gel, and then you need to have reaction with carbon dioxide in the environment, and then the patina starts to form. And the patina, again, which depending on environment, how aggressive it is, it can form within a week to 10 days, and then you're pretty safe. But in that short time period, your surface is vulnerable to damage. And as you saw from that first slide, the top left-hand one, after 48 hours, you've got white rust starting. And white rust can look like that does, which is very superficial. It looks just like milk's been spilt on the surface, and it's pretty benign other than aesthetically unpleasing, and it will weather off, to heavy white crusting, and in extreme cases, even red rust starting to appear in the crust. At that stage, your sheeting is damaged. And ArcelorMittal will have a data sheet called a C1.10, where they give you an idea of the degree of white rust and what you need to do either to restore the surface or to replace the surface.
Dennis, my question was going to be on, do these effects vary, or how do these effects vary depending on where you are in the country? How does region affect, effect of site storage?
Okay, the first and most vulnerable area, of course, is close to the coast. Anywhere where you've got salt spray, and that's going to leave a deposit on the cladding, that sodium chloride is particularly aggressive on metal claddings, metal coatings, I should say. So you have to be very careful. And then, of course, depending on the contaminants in the environment, if you've got heavy industrial pollution, you downwind of a motorway or a takeoff from an airport, you're going to get a lot of sulfur dioxide and nitrous oxide and other compounds combined, which are particularly aggressive to metallic surfaces, but they're also very aggressive on painted surfaces. So the more polluted, the more vulnerable you're going to be.
Okay. Right. Now, thanks for our little tangent that we went on. Do you want to continue with the mechanical damage section, Dennis?
Yeah, mechanical damage to cladding whilst it's being stored. These days, construction sites are very confined and restricted, so you don't have a lot of space to lay stuff out, and often other trades are immediately adjacent to where you've got your material stored, and people then come along and put things on top. So that's one of the advantages of having the tent. It's obviously a soft surface on which you can't put anything. And the slide that's popped up now, that's the kind of damage that can happen. That happened on the surface of a roof after it was installed, but a similar scenario can happen if you're adjacent to building works with a bundle of cladding that's being stored. So those surfaces are a problem from the mechanical point of view, particularly if you get wet mortar on a metallic surface, because there's a chemical reaction between the wet mortar and the surface of the cladding, which can lead to premature corrosion. And of course, which is fatal is where the mortar has not been cleaned off whilst it's still wet and it's been allowed to dry and harden, because then they mechanically remove it. And that's like taking a wire brush onto your metal surface. And bearing in mind, most metal surfaces are only about, well, depending on the source of your material, they could be as thin as 10 microns, but the majority of the products specified in the country is normally around 19 microns thick. And then the next thing, of course, pardon me, are scratches to the surfaces. And if we go to the next slide, you can see the impact. One of the unique things of the metallic surfaces is the cathodic protection, and I guess the best way of describing cathodic protection is like your skin heals when you cut it or scratch it. But depending on how big the wound is, you may need to stitch it. And when you've got a metallic surface, you've got this constant flow of moisture across that surface, which creates this flow of ions, and which is a self-healing process. But once you get beyond a certain width of gouge, scratch, or where the surface has been damaged, the coating can no longer cope, and you will start to get rust spots on the surface of your cladding. When it comes to painted surfaces, they are equally vulnerable. And the bottom left-hand corner shows one of the samples prepared for a salt spray test, where you can see the undercreep, where the cathodic protection is no longer working. It's being consumed, because if you can imagine cross-section through that, you've got probably 8 to 15 microns of primer on top of your steel substrate, and you've got 19 microns of color on the top if you're lucky. And once you've penetrated through that, the flow across the cut edge, if you could imagine the end of a piece of cladding where the edge is cut, on painted surface, you've got just a very small surface of zinc to provide the cathodic protection. And once you got past that, then the stuff starts to corrode underneath, and it'll attack the under surface, and you'll get a delamination. And of course, the big problem is, how do you fix it? And it's not an easy fix. You've got to have someone have a good close look at it and examine it, and decide how you're going to repair it, I guess, is the best way.
That was my next question. Dennis, are there options for repairing mechanical damage?
There's no really long-term option. Your metallic surface, once it's breached to the extent that you're getting extensive rust starting to form, you've got to get rid of the rust. You've got to use a rust converter. and the jury's out as to how effective those conversion coatings or compounds are. And in themselves, they can create yet a further corrosion because they're basically an etching material, which can damage your surface a lot more. In extreme cases, you could try and metal spray zinc coating, but it's expensive and it doesn't really work that well. And from a cladding point of view, yes, you can get a coating that you can put on the surface. But if you go back to that last slide, the picture in the top right-hand corner shows you the difference that you get between an oven-cured paint, which is on the surface of the pre-colored material when you purchase it, and where you've used air-dried material to touch up the paint. And of course, those touch-up paints are nowhere nearly as durable as your original coating. So if you've got a metallic coating and you've reached it to the point where the gouge is that deep or that big that you're getting rust, you're going to have to constantly go back and attend to that on probably a 24, 36-month cycle. Color-coated material, it's going to look terrible, and unfortunately, you're going to have to replace the clad.
Dennis, just related to that question, how does one clean off mortar that has essentially cured on galvanized sheet, since this is such a common problem?
You don't.
Oh.
Once the mortar has dried, the chemical reaction stops. And its biggest problem is that it can cause ponding on very flat roofs. If it's across in a pan where it's blocking the free flow of water, you're going to create a pond. And if you've got a lot of that, I would recommend you replace the damaged sheets, which can be a problem on some of these very large roofs where you've got a sheet that can be 200 meters long and they've got a whole lot of mortar on it. You're going to have to take that sheet out and put a new sheet in.
Okay, and how about before it cures? What would be your suggested way of cleaning it?
Wash it off with water and high pressure water. And I don't mean a high pressure hose, just a normal hose pipe where you can flush it off the surface. And of course, you can use a nylon brush or broom, but for goodness sake, not a wire brush, because again, you're going to be damaging your surface. So the thing is, get it flushed off as quickly as possible to stop that chemical reaction. But then, of course, watch where you're washing it to, because if you're dumping it into a galvanized gutter, you're just transferring the problem.
So using things that you find on Google, such as vinegar or some acid, is not advisable?
Vinegar is, shall we say, a poorer rot for fixing a galvanized surface that's mainly got white rust on it. But it's certainly not going to work that well in taking mortar off. And there are, when it comes to staining, white rust staining, there are several brands, proprietary brands of products, but they're all nitric acid based, and again, use in your coating.
Okay, thanks.
Right, and then the final thing that you've got to watch is temperature. As I mentioned earlier, when you've got products stored out in the sun, where you're going to get a surface temperature between 55, 60, up to 80 degrees, depending on the material. And of course, if you've got a dark black tarpaulin over some white sheets, that surface temperature is going to be getting up to the 80 degrees plus in the environment. And again, it's going to be nice and steamy. And a thing that is regularly overlooked with this type of thing is that the sealants used need to be, they're temperature sensitive as well and have to be stored within a temperature range. And that's often, you go on a site and we'll find these boxes of sealant being left out in the sun for a day or two, and of course by then you've damaged them and they won't perform as the design expected it to.
Super. Everyone else is really quiet. So if you have any questions that are related to this topic, please do pop them in the chat or switch your video on and we'll give them a shot. Dennis, was there anything else that you wanted to mention? I just wanted to say as well that if you've missed any of our previous sessions, they are available on the YouTube page. I've just dropped the link to the playlist for all of the roofing and cladding related topics you can go and have a look over there. Dennis, tell us a little bit about your next session that you're going to be doing. It's on maintenance. Do you want to give us a little bit of a brief overview?
Okay, well, just before we go to that, to wrap up as far as today's topic is concerned, the bottom line is try and avoid storing materials on site for periods longer than a week to 10 days maximum. Otherwise, you're going to be particularly vulnerable. I recently had a very interesting case where some material got delivered to, I think it was Bergville, somewhere in the Drakensberg, in the beginning of December. They then thought they had it all nicely covered. They put it on a tarred road, these bundles of galvanized sheets, covered them with a tarpaulin that they said was tightly wrapped, then came back in January to discover all the sheets had been damaged, and it was a considerable amount of cladding for a chicken farm. So be very careful. Don't store things for extended periods. And I know it's difficult because people don't keep to programs, particularly on construction sites, and the poor roofing contractor invariably ends up with material sitting that he can do nothing with while he's waiting for access to the structure. So it's very important that there's good coordination from the project management team as regarding access and start and finish dates for the different phases. Okay, and then coming up, our next one is maintenance. Everybody says, oh, well, you know, I've got a metal roof, it's got 25-year warranty or 15-year warranty, so I can just leave it out there and it'll look after itself. That's one of the biggest myths in the industry, and it's also the biggest factor in determining whether your warranty is going to be covering the damage that you suffer if you don't maintain your roof. And then after that, we're going to be looking at are you getting what you specified and the risks associated with substitution. Often products are substituted without the specifier's knowledge. And how do you identify the products that you're getting? Are they what you really specified? What's underneath the paint? Is the metallic coating what it should be, etc.? That type of thing we'll be discussing there. And then hopefully after that, SAN 10237 will have come out for comment and we can chat about that.
Super. Richard, I'm going to get to you in a second. I just want to mention Christopher Knight's comment or question in the chat. He asks, is it a wise idea to store coils in a container to reduce the contaminants on site?
Yes, it does, but then you've got to have free-flowing air through that container. Otherwise, you again have created a steamy environment, depending on your environmental conditions at the time. If it's midsummer and you're getting a lot of rain, the last thing is you want to do is lock that material inside the container that's busy steaming the product that's inside. Yeah, it does remove the contaminants, the aggressiveness, but it also drives up the temperature. So you perhaps need a tent over your container, or the most important thing is free flow of air through the container.
Thanks for that, Dennis. Richard van Heerden, you want to go ahead, ask your question?
Yeah, as a Dennis, I'm glad you mentioned the poor roofing contractor a little while there regarding program. Maybe you can have a whole webinar on that alone. But
well,
my main question is, yeah. The staining, the damage caused from sweating on site, at what stage can it be a claim? And is it reasonable for the client to reject the roof?
Yes, depending on the degree of the damage, because the longer those surfaces are together and you've got that electrochemical reaction between them, the coating is being consumed, i.e. thinned out. So the test I always use when asked to look at these kind of things is, if it just looks like milk, live with it unless it's a case of aesthetics, because if you measure the zinc coating underneath, it's going to meet the requirements. If you look at product made by reputable mills and ArcelorMittal and Duferco, and with the aluminium zinc, your Safal products, you're going to have a minimum coating. They always strive for minimum coating. So if you measured the thickness of the coating, it would comply with the requirements. So if it was Z275, you would find you've still got in excess of 19 microns, or AZ150, a similar kind of scenario. But once you're starting to get hard powder and crusting forming, you then have to clean it off and measure the residual zinc coating underneath to see if it has been substantially, or your aluminium zinc coating, whatever the case may be.
And the black staining on the aluminium, all finished?
You're buggered because it'll never go away. You can't get it off.
Correct. So if it's not an aesthetic issue, that's not rejectable. Unless
well, again, you have to measure it. 75 to 80% of the time, you're going to find that there's still the thickness of the coating, which gives you the durability in the environment, is still going to be there. So it'll perform as it was supposed to, except it's going to be unsightly.
No, I'm talking pure aluminium, eh?
Pure aluminium, same applies. So your pure aluminium, if you've got it and you measure it, it's going to be on the surface. But it's going to be there. You can't get rid of it.
So you're saying the staining, the black staining on a mill finish aluminium has reduced the thickness of the material because the entire material is the coating?
No, it depends on the duration and whether the material was anodized or not. Because you will often see it on anodized window frames where they're still silver, that you get these black stains where they had masking tape or tape with a plastic cover. But it doesn't mean that it's the depth you need to establish.
Dennis, I think Richard might be referring to an aluminium sheeting as opposed to aluminium coated sheeting.
No, I'm talking about aluminium sheeting itself. Yeah, I understood him. He was talking about pure aluminium cladding.
But in that case, are you just worried about the thickness of the material then? The thickness of the base material? No,
because if you've got a comma, aluminium sheeting tends to be thicker than steel sheeting, so you're going to be down to 0.6, 0.7, normally the thinnest material. If you looked at that surface and you got beneath it, it's a discoloration, it's not corrosion. So you haven't consumed aluminium.
Yeah, I think that answers my question better. Thanks, Dennis.
Okay.
Thanks, Emmanuel.
So basically what you've got is you've got into the patina surface of it and it's stained, but you haven't destroyed the surface, the material as such. You haven't appreciably thinned it. Don't forget, if you're looking at 0.6, 0.9 material, it's a hell of a lot more than 19 microns of other metallic coating. Is that answered for you, Richard?
So related to that question, Dennis, if you are buying coil or roof sheeting that is imported, can this not happen on the way here? Meaning, on the oceans and seas? And how
depends how it's wrapped, because the mills that produce the coil do have what they refer to as export wrapping, where they've got special papers, etc., that they wrap around, that are moisture absorbent paper, almost like these what do you call the vapor barrier materials. So they hold the moisture away if they can. But of course, if you've got material that's come out as break bulk or something like that, yeah, you could have a lot of problems. It depends how it's wrapped for that period and the temperatures it's exposed to. But most good quality coil comes in containers. But again, have they got something in there to protect it? I mean, if it's coming from a tropical region where there's going to be moisture inside the container, yeah, it needs to be suitably packed and wrapped.
Lenny Naidu, you have a question. You want to just pop your mic on? Yeah, you're on mute, Lenny. You need to unmute yourself.
Sorry, Dennis has already answered the question. Thank you.
All right, which one was that?
The one Richard asked you.
Oh, okay, about the black staining. Okay.
Can you just repeat the question? There was a bit of a feedback echo there.
Yeah. Sorry, Dennis, it was the one Richard asked you with regards to the cladding on the aluminium.
Okay. All right, so we've covered that for you. Yeah.
Okay, cool.
Also, just one thing, gentlemen, remember, when it comes to painted aluminium, you're going to have the risk of damaging your paint coating, not necessarily the substrate underneath. And you need to bear that in mind, particularly if the coating is more than just aesthetic.
Fantastic. Right. This is your
Sorry, one
opportunity.
more, Denise.
Any questions? Yes.
Yes. I know this is rare, but how about stainless steel roof sheething?
That's a whole new ball game. It depends on which material you've got. Have you got a ferritic, which is the 400 series of stainless steels, or whether you've got austenitic, which is with the higher chromium content, which is your 304 and 316. In South Africa, most stainless steel cladding is grade 304. And whilst that might not be damaged by moisture trapped between the layers, the lamina, you can get a phenomenon known as T-staining, which looks like rust. And it is a form of surface corrosion, but it's not detrimental to the performance of the stainless steel. But for example, if you were in Natal and you were going to have it exposed, I would certainly recommend a grade 316 material rather than a 304 if aesthetics are going to be important. Those who are familiar with the waterfront along Umhlanga Rocks, where they've got a lot of, where there's shower stations and things like that, you will see what looks like rust. And it's this tea staining. You see it overseas where they use ice, salt for de-icing. You'll see this thing. But it is a form of corrosion, but it's a surface corrosion.
Right. Any more questions? Pop them in the chat or put your video on and I'll be able to ask you. Just a note on our Steel Awards 2022. Entries will be judged in 2021. So if you have any projects that you completed, any roofing or cladding projects that were completed in the last 3 years, they are eligible for nomination for Steel Awards 2022. I'm just going to pop a link to the website where you can find the nomination forms. And then you can just have a look there. Also on our YouTube page, you'll see some of the nominations from the Steel Awards 2020. Each of our projects that's nominated will get evaluated by our judges in a Zoom call with the project team where they're able to go through the drawings, video footage, photographs of the project, and then just hear from the professional team how the project went, what makes it a unique use of steel or a excellence in the use of steel. Emmanuel, any more questions or comments from your side? You maybe just want to give a little bit of a touch on some of our sessions that you've got that are coming up in future?
Yes, sure. So we have a number of sessions coming up. We did one on purlins, which is related to roofs last week. That was very good. We will do one or a series of them probably on connections. And that should probably pique people's interest because we get a lot of questions on those. The connections are one of the areas of structural engineering that is still sort of not very well understood nor covered in varsity or in the design offices and mentorship programs. So we'll talk quite a bit about that maybe in the next few sessions and focus on it. And then we'll also look at other popular topics such as, for instance, what's going on with, let's say, code development. I think Paulo has agreed maybe to say a few things about that. That's something that people are always curious to know about. And also maybe on a lot of people are designing structures abroad, outside of South Africa, and we can discuss those types of topics of what is the difference, what are the similarities, and how do these international offices work. So I think there's a lot of interesting stuff that comes up, questions that come up in our technical services here. So looking forward to it.
Cool. So one of the joint sessions that Dennis and Emmanuel will be presenting, which is coming up on the 21st of July, is on roof drainage. So Emmanuel will be looking at it from a, how the structural side of it impacts that, and Dennis will be looking at it from the cladding side. Just another question from Christopher Knight for you, Dennis. Sorry, following his previous question, what is SAMCRA's recommendation or guidance regarding storing coils on site should the client not be utilizing the material immediately?
First and number one would be not to have it there anyway. because as long as it's on site, it's going to be vulnerable, unfortunately. So the same rules apply with coils, and they are particularly, because they are so tightly wound, when you get air vapor, the moisture vaporized, they are more susceptible to having it drawn in between the respective leafing, or however you describe the rolling of the material. So try not to have stuff on site, and particularly if you read the conditions of the warranties of color-coated material, is that if they're not stored in a hot, how can we say, an intensive care ward, they can walk away from their warranties. And I recommend people read the conditions of warranty and storage of materials.
Thanks for that, Dennis. For those
Has that answered Christopher's question?
yes,
Is he happy?
Chris, just pop a. Oh, there you are. Now we can see.
Sorry, I thought I'd show face today. Sorry, Dennis. It's just that we get a lot of investors obviously wanting to purchase the coils beforehand, and obviously for them to get paid out or to retain the fee, well, that price, they want the coils delivered to site. So is there no, obviously from SAFOL's side, we obviously have our T's and C's, but is there no real way of storing this material on site? I've mentioned the container, but obviously I did mention the temperature variance as well as moisture retention within a container. So how do we get around this? Obviously in that container, if we have to use it, obviously we're going to put it as a slant or on dunnage. It won't be directly onto the floor. What else can we recommend these guys to do?
If they're insistent on the material being on site, you basically need to have it in an air-conditioned container, which is a ridiculous scenario. And in my contracting days, the way we overcame this kind of problem was to say to the people, come to the factory with your auditors or whatever the case. We'll identify the coils we've put aside for you. They're stored under the ideal storage conditions. And we'll give you a certificate of ownership of those coils. Then they're kept in prime condition in the right environment. Also bearing in mind that often when you're dealing with high tensile materials, there's a limit to the period from the time the coil is manufactured to the time it is converted and profiled. You get a thing, strain hardening and that kind of thing. So there's a lot of risks involved in storing materials for extended periods of time. But that's the simplest. If they want to be secure, they can come and buy the coils and you store them on their behalf.
Okay.
Then ownership is transferred as well.
Okay, perfect. Thank you.
Dennis, that actually brings up another question from my side. And I'm by far not a technical person, so this may be a dumb question. But what other issues come up besides staining when coils are stored? Is it, you mentioned something now that I was like only half listening, but what are some of the other issues that might come up when the material is stored?
Well, mainly mechanical damage. You can get somebody bashing into the side of a coil. You can get somebody bashing into a pack of cladding. Sometimes the cladding can be panel beaten back without any serious damage, provided it's not painted, of course. That's one of the advantages of a metallic coating, is that they're malleable and you can knock the thing back into shape, provided the coating hasn't been scratched off or that type of thing. And then, of course, as I mentioned before, things being splashed against it, that type of damage. So the big, other than the moisture one, which is the most critical one, the mechanical damage is the second most problematic. So yes, things can be repaired, but if they're broke to their point, for example, if sheets have been moved by someone other than the cladding contractor and they've broken the back, in other words, they've caused a rib to collapse or buckle or crack, that sheeting may well have to be scrapped. So it's very important that if you've got material on site and you're a roofing contractor, that you've got someone watching your material if you had to go off site for some reason or other. And no one moves that sheeting. The big thing is don't.
Did you have another question, Emmanuel?
Yes, Dennis piqued my interest here. Can you elaborate on what you said about this time period between coil manufacturing and rolling, since we do a lot of site rolling these days? This sounds like a very relevant topic.
Yep, there is. I mean, if you get these buildings in, I'll refer to the 2 previous years' steel awards. There were some warehouses with curved roofs where the sheets were, I think, in excess of 100 meters long. Getting that sheet up onto the roof is a challenge. And it looks like a caterpillar climbing up the roof. You have to build a ramp and you have to have people at reasonable distances apart so that you don't overflex the material and damage it. And of course, getting over monitors and that type of thing. But that's a whole separate thing. And perhaps we can cover it in a future session where we discuss curved roofs.
Yes, but my question was more about, you said something, I may have misunderstood, that there's a time period in which you have to do the rolling after the coil is manufactured for high strength coil.
Yes.
What is that? Yeah.
It's a form of strain hardening. And if the coil has been stored for 18 months, for example, you could have some problems with that material when you come to roll forming it, depending how severe the forming is and how quickly the distance between the stages of the roll forming mill as to how vulnerable that material is going to be to cracking.
Thanks for that, Dennis. So we have got some sessions coming up. If you joined this Zoom call, by having a look at something that was online or a friend forwarded it to you, here is the sign up link for our notifications of these future sessions. I've just popped it in the chat. If you'd like to receive notifications about sessions that are coming up, just make sure that you subscribe over there. And then also what I wanted to let you know is if you're curious about topics that are going to be coming up in future, this link over here to the SAISC's website, which I've just popped in the chat, is where we will put all the topics that are coming up. We really are looking forward to sharing topics that are of interest to you. So if there's something you'd like to know more about, or there's a topic you'd like us to cover, just pop us an email. You can send it to Dennis at saisc.co.za, or you can send your question to technical@saisc.co.za. I'll pop those mails in the chat now. Dennis, is there anything that you'd like to say in closing, or anyone else, if you have a question? Now is your time to either switch on your camera or pop your question in the chat before we close. Dennis, I'm going to hand over to you, and then if anyone has any questions, I will pick up on that.
All right, we've got a number of courses coming up that we're going to be offering, and again, some of them are CBD accredited, so we're just waiting for the accreditation points to be allocated. And there's Cladding 101 for engineers, and Cladding 101 for quantity surveyors. Then for architects, we've got the finer points of cladding. And from the contracting side, we're going to be doing Site Supervision 101.
I see Chris's camera is was on. Chris, do you have any more questions, or are you just wanting to show us your face again?
Sorry, it's just to obviously answer Emmanuel's question from Saffold Steel side in terms of utilization of material. We generally specify that the material should be utilized within 6 months of the production date.
Thanks for that, Chris. Right, so if nobody has any more questions, I think we are going to close.
Hey, Denise, I'm going to respond to that.
Yeah, go for it, Richard. Do you want to just pop your camera on?
I'm ugly enough, man. You can know what I look like, but I'll go for it. Krista, you said 6 months. It just perked my alarm here. At the moment, that sounds a bit unreasonable. So what are we saying? After 6 months, it's not usable?
No, it's just a recommendation to obviously utilize that coil within that duration of time. It's just due to obviously the possibility of being exposed to contaminants or storage thereof. Obviously, we can't govern once the coil leaves our floor how that material is actually being utilized or stored. So it's just a guideline as to when to utilize that coil or time period.
So after 6 months, what happens?
Depending on the the condition of the coil, obviously your warranty may get affected.
Stored in a warehouse?
Look, we could probably inspect it. I would have to speak to obviously my technical managers to inspect that, ensure that the material is still intact as per when it left our floor, basically.
I'm just in terms of what you brought up the subject, currently, because of the shortage supply of material, there's a lot of stockpiling of materials prior to a job occurring. And as Dennis alluded to earlier, the programs never occur the way they should. So a job starting in July can easily start December. That's not outside the realms of possibility. But to get that material, I would have tried to procure it in March almost now, and having put it aside, kept in a warehouse. So that's long after. I think there's quite a bit of buildings going up right now, well past the 6 months phase. So that's why. Sorry, I was about to switch off, but then you said 6 months. That sounds very concerning under the current circumstances.
As far as I understand, it is a standard throughout the industry in terms of coil manufacturers, is that that's just a guideline to utilize. Obviously, it can be dealt with on a case-by-case basis, I'm sure.
Richard, I think one aspect you need to look at is who has ownership of the coil and who is responsible for the storage. And that's the one aspect. The other aspect is you need to ask the profiler whether they have any anxieties about material that is more than 6 months, high tensile material that is more than 6 months old, and the roll forming of it, whether there's a risk. So you would need to obtain an indemnity.